StepFun-AI has launched Step1X-Edit, an image editing model whose performance is comparable with Gemini and GPT-4o. This model is open weights, so they've released this model on Hugging Face. So in this video, let's try to understand what is Step1X-Edit, and let's look into comparisons of Step1X-Edit with GPT-4o and Gemini 2.0 Flash. We'll also look into the architecture of this model, what are its memory requirements. So this model can perform the following edit operations. It can do motion change, it can do material modification, it can do subject addition, it can do style transfer, it can do text modification, color alteration, background change, subject removal, and a lot more image editing tasks. So they have this demo image. This is a GIF image where they show all the operations like changing the background to a mountain, adding a necklace, okay, adding an object basically, change hair color to white over here, make pixel art style, remove the girl, okay, make her cry over here, change the word to step fun, text alteration, again text alteration over here, change to dark theme, make it colorful, change of tone, change water to ice, okay, open the bride's eyes over here, right, make ice gold, material change, and so on. So this is their demo image. Okay, now let's go to their GitHub and see what is the memory requirement for this particular model. So for this particular model, depending upon the input image resolution, okay, or the output image resolution, you would require close to at least 42.5 GB for a 512 into 512 image output. For 1024 into 1024 image, you require 49.8 GB. The recommendation is a 80 GB of memory for better generation quality. So that is the recommendation. Let's just compare over here from their paper of how this model works when compared to say Gemini or GPT-4o. So this is an input image, and the first task is tone transformation, restore and colorize this old photo in high definition. You can't really look into the details over here in this paper of these images, but then if you just look at it at a high level, you see Gemini is kind of oversaturated over here. GPT-4o looks a bit natural. Step1X-Edit is somewhere in between. Right? It is comparable to Gemini and GPT-4o in this tasks. You need to really zoom in and see if what are the minor differences or what are the specifics between these images. Okay, I'm not looking at other tools over here. The other tools are open source. I'm just going to look at Gemini, GPT-4o, and Step1X-Edit. So the next task is text modification. The original image is this: replace the train with plane. And if you look at Gemini, it is replace snow also over here. It's made this area as black over here. If you look at GPT-4o, it's done a good replacement over here, and even Step1X-Edit is also good over here. If you look at the images, Step1X kind of retains the style of the snow train over here. GPT makes it kind of flat. Here it is still 3D. Okay. The next one is transform it into a Ghibli style or a Ghibli style. So this is the original image, and this is Gemini's output, which is quite good. This is the output of GPT-4o. I don't know why they are showing two images over here, and this is the output of Step1X-Edit. Step1X-Edit also has done a good job over here. Okay. The next one is portrait beautification. Remove his beard. So original input image is this. This is Gemini. Kind of the face identity is maintained. GPT-4o, the face identity is not maintained. The facial expression is changed. Step1X-Edit has done a good job over here. Okay. This is motion change. Make the person in the image give a thumbs up. So if you look over here, this is Gemini. GPT-4o is also good. Gemini is also good. GPT-4o changes the expression of the face to a little bit smiling face, whereas Step1X-Edit has also done a decent job over here. Okay. The next one is material modification. Replace the sword in the image with a diamond sword. This is still okay, but Gemini just drops the knife or the sword below. GPT-4o messes up it over here, whereas Step1X-Edit does a good job. Change the color of horses to violet. So here are the horses. So this is GPT-4o, which is slightly better. Here it is converted to violet, and whereas Gemini kind of messes up over here. So here it is Gemini 2.5 or 2.0 Flash, GPT-4o, OpenAI, and Step1X-Edit. This is background adjustment. Adjust the background to a garden. So here you have the original image. So if you see, GPT-4o has gone into some kind of cartoonization, whereas Gemini does a good job. Even Step1X-Edit does a good job. Okay, this is subject addition. Light the candle to enhance the candle light. So this is, if you look at Gemini, it kind of changes the image over here. The candles are changed. GPT-4o is good, and this is from Step1X-Edit. Okay, so GPT-4o kind of makes the room also a little bit dark, so kind of candlelight lighting. Then you have subject removal, erasing this stop sign over here. Good job by Gemini, good job by GPT-4o. Gemini kind of erases the car also over here. Maybe the color is same. Whereas Step1X-Edit does a good job. It also does a deletion of the stop sign. Okay. Here we have subject replacement. Replace the school bus with a truck. So here is a school bus. So this is Gemini, kind of replaces it with a truck. Okay, in the American context, I think even these kind of vehicles are known as trucks. This is a real truck. Step1X-Edit has done a good job over here. So this is a comparative illustration of open source approaches and commercial systems for enabling English editing instruction. Okay, so that is a comparison which they have done over here. These are select images. Unless you run the model and see, your performance may vary from select images put into a technical report. Okay, so in the technical report, they talk about the architecture or the framework of this particular model. So you have this input image, okay, which you want to edit, and you are giving a text instruction, remove the boy. So this text plus input image is given to a multi-model large language model. Okay, so they use Qwen 2.5 EL over here. That gives you a joint instruction and image embedding from the LLM, which is then fed to a lightweight connector. Okay, then there is a diffusion image transformer. There is a variational autoencoder image which gives converts the input image to latent, on which noisy latent is added and fed to a diffusion image transformer. Okay, the output from the diffusion image transformer is again in the latent space, which is converted, decoded by a variational autoencoder to your final target image. But in the middle, what happens over here is from the instruction and image embedding, the connector, what it does is that it takes the text plus image part and it gives to the text embedding part of the DIT, diffusion image transformer. It also builds up a global visual encoding or visual encoding guidance vector. Even that is given to the DIT for performing the image editing, to generate that image with the editing instructions basically. Okay, so this is the framework of Step1X-Edit. Now if you were to look at, as I said, the model architecture, I talked about this MLLM, which takes the reference image and user's editing instruction as input, jointly processes them to understand the semantic relationships relevant to the editing task. Then you have this connector module, a lightweight module that processes the token embeddings of the multi-model LLM. It refines these embeddings into a compact textual feature representation used for conditioning the diffusion model. Okay, and it also calculates a global visual guidance vector from the MLLM output, which guides your diffusion image transformer. So the diffusion image transformer is a diffusion based image decoder. It receives a noisy latent representation of the image from the variational autoencoder, the refined textual features and global guidance vector from the connector, and an encoding of the reference image. The DIT iteratively refines the noisy latent to the target image latent, which is decoded by the variational autoencoder over here. So that the decoder takes this latent and gets you the final image. Okay, so what they do during training is they do a joint training. The connector and DIT are trained. Okay, and the model components are initialized with pre-trained weights. That is the Qwen VL for your MLLM, and DIT text to image model is Flux. Okay, so during training, what they do is that they feed both the target image as well as your original image along with the textual instructions are encoded by the VAE. The target image encoding is noised while the reference image encoding is not. These two set of image tokens are concatenated to form a visual input to the DIT. Okay, this is their strategy to enhance reasoning over contrastive context. That is during training. Training loss function is diffusion loss. Okay, but during inference only the reference image and text is given, which goes through this VAE. The image plus text goes to the MLLM, and you get this joint instruction plus image embedding, and it goes through connector DIT finally to generate your image. Okay, so this is the architecture of this particular model. So they've also created a lot of training. They've explained how they have created their training data set, which is also interesting. So what they do is that they take an image and they make use of Florence 2 to get what is present in this image, which is then fed to SAM2 to do the segmentations of the image. So now they have for the same image, they can have an original to target like removing the building. So that mask is available. So you have a target image with the building removed. You can also have another pair whereby adding image to this original image. Okay, whereby this building is removed. So in this case, in this way, they create edit instruction triplets. Original image, there is an image with a certain part removed or added. Okay, and you have the instruction. So they create these triplets for training. Okay, similarly for subject replacement and background change, they again make use of SAM2 from the original image. They use Qwen 2.5 EL to recognize anything, magic, fan, large. So basically this thing. and then they produce a target image with flux fill, okay, whereby an object is removed. So now they have an instruction like this: replace the tape on the right side at the center with the colorful magic folding fan arranged at an angle. So that is the instruction. Source image, target image. Okay, like this they also create source image, target image for color alteration and material modification, whereby they use depth and mask. Okay, then they use control net to replace it with the color, and then they have the target image. So in this way they have created a triplet: original image, target image, and instruction for color alteration and material modification. For style transfer, they again make use of control net SD 3.5 to create original target versus original image versus target image. Okay, so they create this pair over here. For motion change also, they make use of bi-refnet plus raft filtering, some method they use over here for creating motion change triplets. For portrait editing and beautification, they make use of a human editor to edit photos over here and then create target photos. For tone transformation, they use color adjustments, image editing to create triplets. Text modification, they make use of OCR and then they create manual text editing they do to replace the text to create source target pairs. So in this way they are able to create triplets for your training process. So this particular model has been released on Hugging Face. Okay, they have also released a benchmark of close to 1200 images which can be used for testing your image edit models. Okay, so they have released this benchmark where you have instruction language both in English and Chinese. As I saw, you have input image, you have output image. Okay, so this can be used for your training as well as for testing your image editing models. Step1X-Edit, a model for image editing, which is an open source model or open weights model, which is much more closer to your GPT-4o or Gemini 2.0 Flash, which are closed source models. Hope this video on Step1X-Edit is useful to you. I'll put all the links in the description of the video. See you in another video.